Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you as you step into my virtual classroom where we've now entered a new year, a new decade, actually, even, and we have Seahawks, Packers in the background. Seahawks must have scored. They're kicking off. Let's see. They got a field goal. I kind of want the Seahawks to win because I want to see a nice Seahawks-Niners They've had some close games in the end here. Since the Niners can't play the Ravens or Patriots in the Super Bowl, I figure we might as well have a great NFC championship game. So go Seahawks on that front, even though I want the Niners to win anyway. All right, I want to go ahead and get started here. What this video is on, the next unit that I'm going to teach is on systems of equations. If you don't know what that is, I guess that's why you're going to be here. But prior to going into solving systems of equations, you need to know how to be able to do a few things. Number one is you need to be able to graph a linear equation as it's written. I'm going to look at a slope-intercept form equation and a standard form equation. Those are the first two problems I'm going to do. I got 8 problems I'm going to do, by the way. Second thing you got to be able to do is understand what it means to be a solution to an equation or to part of a system. And that's what a problem's going to be. I got a few problems on simplifying expressions, whether it's distributing or combining like terms or something like that. And then solving equations, just a linear, getting a variable by itself kind of thing. All right? Maybe distribution involved with that as well. I can't remember the problems. Anyway, 8 practice problems. Going to jump into these pretty quick. Not going to do much teaching in them because I've taught them before. So if you want to see an old video that refers to this stuff and go back to here and say, okay, these are the things I need to know how to do, that's fine. Just go ahead and do that. Obviously do what you need to do. This one is not going to be on systems of equations, though. I'm saving that for the next video, which will probably be during this Packer-Seahawks game because I want to get some exercises in solving by graphing. But in order to solve by graphing, you got to first know how to graph an equation. That's what I'm going to first do here. I have 2 equations, one in slope-intercept form, y equals negative 3/2 x plus 4, and one in standard form, 2x plus 5y equals 15. Okay, number 1. Let's graph y equals negative 3/2 x plus 4. Now this is written in slope-intercept form, which is y equals mx plus b, where m represents the slope, in this case negative 3/2, and b represents the y-intercept. In this case, it is at the point 0, 4. In order to graph this, I'm going to start from that y-intercept 0, 4. I need some good reference point to kind of hit in there. And then I'm going to use this slope of negative 3/2. Negative, if I apply it to the 3, that means a rise of negative 3, which means a fall of 3. I'm going to fall 3 and run 2 to the right. And there's another nice pretty point I can plot this thing on. I'm going to continue that over and over as it is linear equations. Fall 3, run 2, and fall 3, run 2. There we go. That's going to work out for those points. If I could fit any other points up here, and I'll make up one, I'm going to rise 3 and then run 2 to the left to kind of stay on that line. Now it's like the 3 is positive and the 2 is negative, which still leaves me with a fraction of negative 3/2. So let's go ahead and draw that graph. You have a ruler, just draw that line that goes through, and there is the graph for that equation. So again, in order to solve systems of equations by graphing, you have to be able to first know how to graph these equations, specifically linear equations, which is what I'm working on. Okay, number 2. Let's graph 2x plus 5y equals 15. Now currently it's in standard form, so I'm going to first set it up in standard form, but based on my graphing window range, I see a bit of a hiccup that might cause a little bit of trouble. Maybe I won't fit my point perfectly. You'll see what I mean right here. In standard form, it's really easy to solve for the x and y-intercept. If I can find the x-intercept and y-intercept, because all I have to do is set the other variable equal to 0. For the x-intercept, I have to set y equal to 0, and for the y-intercept, I have to set x equal to 0. And what I mean by it being easy is, all I do when I set something equal to 0 is it kind of goes away. I'll show you the y-intercept first right here. If I find the y-intercept by setting x equal to 0, 2 times 0 is 0, and 0 plus 5y is 5y. So it's like this whole term just goes away. So I can essentially hide it. And I'm saying the word hide specifically because after I hide, I have 5y equals 15. Now I'm going to divide. So I call it hide and divide. I kind of made it up while I was teaching a class earlier this year, so it was nice. 5y equals 15, that means y equals 3. So when x equals 0, y equals 3, that is one point that is on this graph that I can use right there, 0, 3. The other point, the x-intercept, remember we set y equal to 0, so this time instead of hiding x and dividing the coefficient in front of y, now I'm going to hide the y term, setting y equal to 0, same thing. I have 2x equals 15, divide both sides by 2, x equals 15 over 2 here. Now, as an answer, that's fine, but as a graph, you kind of want to know what that number means. You might not have a calculator in front of you. This does convert to 7.5 or 7.5, and that's not the troublesome part. That's okay. I can still use that. The problem is my graphing window range, as you can see, ends at 6, and even if I wanted to outstretch it like I did this one, I kind of go off the line here. So 7.5, I'll kind of mark it off the end of the screen if you can see it right there. 7.5 is going to be kind of close to right there. Okay. So I could essentially just draw the line right now because 2 points are enough to make a line for you. So I could just connect these dots right there and I'd be set. Now, like I said, that one's a little bit off the screen. I do want to show one other particular instance in how to do this. Maybe you don't like graphing in standard form the way that I presented. Maybe you prefer slope-intercept form, and a lot of people do. It's something that you're going to grow up doing and liking and just learning and loving. So I'm going to go ahead and take this equation one more time, but I'm going to rewrite it in slope-intercept form by getting y by itself. So I have 2x plus 5y equals 15. If I go ahead and subtract 2x from both sides, I get the 5y term all alone on its one side of the equation there. And I'm going to go ahead and have 5y equals, now if I want to get this in y equals mx plus b form, I need the negative 2x term to appear first. So 5y equals negative 2x plus 15. Okay. Now I'm going to go ahead and divide both sides by 5 here. And when I divide by 5, everything's got to kind of divide by 5. All three of these terms right here. And I'm going to get an equation now that says y equals negative 2/5 x plus 3. This equation appears different than my original standard form equation, no doubt. But there is no actual difference between these two things. I'm going to go ahead and bring it up. Whoa, that kind of changed. I'm going to go ahead and bring it up to the top here. Give me a second. Let me scroll this guy up. And here is that equation, y equals negative 2/5 x plus 3. But now if I graph it based on its characteristics, because now that I'm in slope-intercept form, is now I use that slope of negative 2/5 and the y-intercept of 3 to kind of play with grabbing more points that I need. It's not just about the x-intercept, and the y-intercept anymore. So let's go ahead and do that. Now, I kind of already have the drawing, so I'm just going to continue on what I have here. I start at 0, 3 like I would have before, so that's nice. I still have that point. But now if I use my slope, I go down 2 and right 5. So down 2, right 5, and that's where I would arrive at that point right there. It's not on the x-axis, it's not an x-intercept, and that's fine. I can still use that point. And likewise from the previous one, from here I could also rise to as long as I go left 5, and then that's this point right here. So I can find another way to graph that thing if I have to do the work for it. Just got to convert my equation. Whatever you're most comfortable with, make sure you do that as well. And that is how you graph equations in slope-intercept form and standard form. Likewise, you also saw how to convert an equation from standard form to slope-intercept form right there. Okay, moving on. Number 3, I have a point, and I want to know if it's a solution for the line y equals 4x plus 2. Use substitution to verify. Now, two things to this because I want to make sure you kind of know both. I'm not going to really answer it this other way, but when it asks if something is a solution for an equation, what we're also asking is, if I plotted this point, would it fall on the line that this graph makes? So I'm not going to graph it like very detailed, but let's say you have y equals 4x plus 2. That means I start at 0, 2, and I rise 4, run 1, rise 4, run 1 like that, and I get a graph, this big line that kind of goes like whatever like that. The question is 8, 36 existing on the line or off the line? Does it look like that, or does it look like it hits on the line like that? Now the 8's clearly not in the right spot. If the 8, 36 did hit that point right there, whatever. If it does hit the point, that means it's a solution to the equation. If it doesn't, that means it's not a solution to the equation. That's graphically. But if we use substitution to verify, if we do this algebraically instead, what we can do is we can substitute 8 in for x and 36 in for y into this equation. And then we can find out if we actually get an answer that leads to a correct statement. Okay. So y equals 4x plus 2 here. I'm going to go ahead and substitute 8 for x and 36 for y. So we're going to go ahead and do 4 times 8 plus 2. There's a lot of room here. So I have 32 plus 2. Does that equal 36? Well, it looks like it equals 34. 36 equals 34. Nuh-uh. This is a big no-no. I'm going to go ahead and just say, use substitution. Is it a solution? No, it is not a solution. Because when I substituted it, the left side didn't equal the right side, of course. And also, when you saw that on that graph, you saw that the point, well, you didn't see it on the graph because I didn't draw the proper graph. If you graphed this, that point would not be on this line. Okay, it would actually be just a little bit underneath it, if you wanted to know. All right, numbers 4, 5, and 6, I'm going to simplify. They involve distribution and combining like terms, possibly. So let's see what we can do here. Number 4, let's simplify this expression. The opposite of 3x minus 2y plus 4. Essentially, with these parentheses here, what's saying is you're taking the opposite of the entire term quantity, which means every single term is going to go ahead and take an opposite effect of what it has. If the value is positive, it will become negative. If the value is negative, it will now become positive. And the 4 is positive, so it will now become negative. So that becomes my result. No terms are alike, so nothing can combine. I just distributed the negative. If you want to think about it another way, pretend like this number was a negative 1, because that doesn't change my values, and that's essentially what's happening there. It's implied that a 1 is there, and I just go ahead and use that. Negative 1 times 3x is negative 3x. Negative 1 times negative 2y is positive 2y. Negative 1 times 4 is negative 4. That's it. We're simplified. Number 5. 5x minus 3 times the quantity 2x plus 4. And again, we're not solving for x. We're just simplifying. Simplifying meaning no parentheses, all like terms combined. So I'm going to start with the distribution term. Not only can these not combine, but I do not do this first. Subtraction does not occur before multiplication. So I'm going to multiply this right here, but be careful because just like this was a negative 1 of sorts, this is actually a negative 3. I have to distribute the negative 3 into 2x, which becomes negative 6x, and the negative 3 into a 4, which becomes negative 12. A lot of people forget about turning this one negative or changing its sign because they only think of this being as a minus here and forget that it's not just a 3 that's distributing into this, but it is a negative 3 really that's distributing, so it should change all your signs. By the way, there's still a 5x right here. So now that I've distributed the negative 3 into both terms, I can now combine like terms. 5x minus 6x is negative 1x, or as some people might just put, negative x. And that minus 12, which combines with nothing, is also going to hang out and subtract with the negative x. I get negative x minus 12. All right, last one is simplification. Number 6, I have 4 minus 7x plus 7x. Let me give you a wrong answer first in red. This is wrong. What's wrong? Don't just combine these two 7x plus 7x, call it 14x, and say, hey, this is 4 minus 14x. This is wrong. The problem with that is treating the 7x plus 7x as if addition comes before subtraction. See, here multiplication came before subtraction. Addition doesn't come before subtraction. Addition and subtraction are on the same precedence. So you go by the order of what they're written, left to right, or you just consider it as this 7x is actually a negative 7x. So if you want to combine like terms, you have to. That's fine. Go ahead and do that. But it's not 7x plus 7x. It is negative 7x plus 7x. Negative 7x plus 7x is just 0. So this becomes 4 plus 0, which is, of course, 4. Your result to that is 4. Okay? Think of it as just 4 minus 7 plus 7. If you take 4, subtract 7, and add 7 back, you're back at 4. Because the negative and positive 7s canceled each other out. That's the thing. I feel like this should have been the first problem, but that's okay. All right, 2 more problems here. Number 7 and 8, we're going to go ahead and solve these 2 equations here. Now we are solving for x, getting it by itself. And again, when you get a solution, it means that if I substitute that value into the equation, that means the left side would equal the right side. What's happening goal line back here? I'm going to check out what's happening. Did they try and make it in? Looks like Packers might have scored another touchdown. Not very happy about that. All right, here we go. So 4x plus 2 equals 6x minus 8. Let's get x by itself. In getting x by itself, I also have to get the constant terms by itself. I have to move things out of the way of x. I like my x terms positive. If I subtracted 6x from both sides here, I would end up getting a negative x term. It's not terrible. I just like my x terms positive. It's a little picky thing I do. So I'm going to subtract 4x from both sides. I'd prefer to do that myself. And in subtracting 4x from both sides, the x terms go away here, which means all my x terms are going to move here, where I'm going to have now a 2x. With the negative 8 and positive 2 here, if my 2x is over here, that means I have to move this negative 8 over by adding it to this side here. And of course, it's going to add with the 2. So negative 8 plus 8 is 0. 2 plus 8 is 10. Now I have an equation that says 2x equals 10. Okay. And if I divide both sides by 2 here, I'm going to go ahead and get x equals 5. X equals 5 is the solution to this equation. That means if I substitute 5 back into this equation, all things work out. 4 times 5 plus 2 is 22. 6 times 5, which is 30, minus 8 is 22. 22 equals 22. That's the x value that makes this thing work. All right, and the last problem here is it involves distribution, and there is an equation. But what I want to do, I'm going to split these two sides up right here. I want you to really focus on the fact that I'd love to just simplify this side first before I do anything with that side. I'd simplify this side too, but it's already simplified. That's 16. Let's go ahead and play with distribution like we did last time. This negative 2 is going to distribute into both terms here. And I'm going to get negative 2 times 3x is negative 6x. And negative 2 times negative 5 is positive 10. So I have, there's an equals, negative 6x plus 10. And I also still have this 4x hanging out right there. All right, so I've distributed. I'm not done simplifying though, because I have like terms that can still combine. 4x minus 6x is negative 2x. So I have negative 2x plus 10 equals 16. Okay, I think I'm good with the great barrier right here. I'm just going to get rid of that. Negative 2x plus 10 equals 16. Let's go ahead and solve for x. While I said I do like my x terms to be positive, it's already on this side of the equation. Why not? Let's not overcomplicate things, do more than we have to. Let's just go ahead and move the 10 over by subtracting. I'm going to get now 2x, negative 2x, excuse me. That's why I don't like them negative. Negative 2x equals 6. And we have to divide both sides by negative 2 now, okay? By negative 2. That's something, a lot of people say divide by 2. You got to get a positive x. Got to divide by negative 2 there. We're going to get x equals negative 3, as 6 divided by negative 2 is negative 3. As a double check here, 4 times negative 3 is negative 12, minus 2 times 3 times negative 3 is negative 9, minus 5, let's see if that's 16 here. That's going to become, remember, I can't subtract these yet. The negative 2 multiplies with what's inside here. I don't have to distribute here because I can combine these like terms. It's negative 12 minus 2 times negative 14. Let's see if that becomes 16. That's negative 12. Negative 2 times negative 14 is positive 28. Negative 12 plus 28 equals 16. Well, this is the same as 28 minus 12. Does 28 minus 12 equal 16? You betcha. So 16 equals 16. And that checks out. That means that's our proper answer. All right, those are the only problems there. That ought to do it for me here. The next video I'm going to do is going to be solving systems of equations by graphing. But like I said, I wanted to start off with a little bit of preliminary stuff, making sure you know how to graph linear equations, know the different forms, understand what a solution to an equation means in particular, know how to simplify expressions, because then you got to know how to then solve them there. The next video that I do won't really be with solving equations, just graphing them. And then after that, we'll be solving equations in a couple other sections using a couple new methods called the substitution method and the elimination method for systems of equations, specifically linear equations. Okay, so that ought to do it for me. My name is Mr. Robinson, and thank you for watching.